So let us take some examples. So first, what is the combined equation of the lines 2x plus 3y is equal to 0 and x minus y is equal to 0? As you can see, I have taken two special lines. These are lines passing through origin. So if two lines, both the lines pass through origin. If both lines pass through origin, that is the constant term in the first equation and the second equation, if both are equal to 0. So let us see how the combined equation looks like. The combined equation is nothing but 2x plus 3y times x minus y is equal to 0. That is 2x square minus 3y square. 3y into minus y is minus 3y square. Minus 2xy plus 3xy. That is plus xy is equal to 0. So as you can see, if there is no constant term in the equation, you have only three terms in the final equation of pair of lines: the x square term, the xy term, and the y square term. That is, you have only the quadratic terms. You won't have the linear term. You also won't have the constant term. So remember this, if both lines pass through origin, then the equation of pair of lines will be a homogeneous equation. Homogeneous simply means that every term will have the same effective power of variable. That is, the first term has a power of variable which is equal to 2. The last term has the power of variable is equal to 2. The middle term also has the effective power of variable equal to 2. That is, x has a power of 1, y has a power of 1. So the effective power of the variable is 2. So if each term has the same power of the variable, then such equations are called homogeneous equations. So if the lines pass through origin, you get a homogeneous equation. So you get a maximum of 3 terms. And if the lines do not pass through origin, you have a non-homogeneous quadratic in x and y, where you get a maximum of 6 terms. You have an x term, y term, and a constant term in addition to this. Let us go to the next example. So let us deal with a slightly changed equations. You have 2x plus 3y plus 1 is equal to 0 and x minus y is equal to 0. One line is not passing through origin, the other line is passing through origin. And observe that the linear part of both these equations is same. Now if you multiply, if you want the combined equation of this, you get 2x plus 3y plus 1 times x minus y is equal to 0. This implies 2x plus 3y times x minus y plus x minus y is equal to 0. So 2x plus 3y times x minus y has already been calculated. This implies 2x square plus xy minus 3y square plus x minus y is equal to 0. So as you can see, if one line passes through origin and the other line don't pass through origin, you have an extra x and y terms now, but the constant term is still equal to 0. If either one of the lines pass through origin, the constant term will be equal to 0. If both lines pass through origin, the x and y terms are also equal to 0. So if one line is passing through origin and the other does not, you have an xy term, and you can very clearly see that the quadratic expression is exactly same as this expression. That is, the quadratic part of the pair of lines depend only on the linear part of the lines. If the linear part of both the lines is same, then the quadratic part of the pair of lines also remains same. Next, let's go to the third example. So we have 2x plus 3y plus 1 is equal to 0 and x minus y plus 2 is equal to 0. So again, I am keeping the linear part intact. I am just adding the constants. So you have the combined equation as 2x plus 3y plus 1 times x minus y plus 2 is equal to 0. That is 2x plus 3y times x minus y, 2x plus 3y times x minus y plus 2 times 2x plus 3y plus 1 times x minus y plus 2 is equal to 0. So this implies the combined form is exactly same as this. So 2x square plus xy minus 3y square. So as long as you don't change this part does not change. Plus 4x plus x is 5x. 6y minus y is 5y plus 2 is equal to 0. Now these two are generally equations which are not passing through origin. So you can see that you got all the 6 terms. You got all the 6 terms. But the quadratic part did not change in all the 3 equations. As you can see, these 3 lines are parallel to each other. These 3 lines are parallel to each other. So all these pair of lines represent a pair of parallel lines. This set is parallel to this set is parallel to this set. So as long as the pair of lines are parallel to each other, the quadratic part does not change. And the direction of the lines, as you know, the slope of the line is determined by the linear part of the line. Slope of individual lines is determined by the linear parts of the line. So if you leave the slopes intact, the quadratic part also does not change. So in the pair of lines, the quadratic part determines the direction of the lines. The quadratic part determines the direction of the lines, and the linear and constants determine the constants or the position of the lines. So I hope you have understood how to find the equation of pair of lines if the lines are given. So let us take another example to show what you should not do. Sometimes some students tend to get it wrong. So what students tend to do is, if the question is given like 2x plus 3y is equal to 1, if this is the first equation, and x minus y is equal to 2, if this is the second equation, if you're asked to find the pair of lines, if you're asked to find the equation of the pair of lines, what sometimes students tend to do is, they tend to multiply these two is equal to the multiplication of these two. It is 2x plus 3y times x minus y is equal to 1 into 2 is 2. So this is wrong, because it does not give the same answer as you do in the previous method. So the correct method will be, first write the whole expression is equal to 0 and the whole expression is equal to 0. First write the lines in the form L1 is equal to 0 and L2 is equal to 0. So 2x plus 3y minus 1 times x minus y minus 2 is equal to 0. So this will be the correct equation of the combined equation of pair of lines. This is a wrong way. Just keep in mind, you should not do this. This is a wrong way. So you cannot directly multiply as long as the right hand side is equal to 0. You can only multiply if the right hand side is equal to 0.